Problem here too. How many people, when you saw this, it made you ill? It should. Why should this make you ill? It is a hack, but there are good hacks and there are bad hacks. And this is in the category of bad hack. And unfortunately, this is done too much in a lot of the Ruby DSLs that are out in the world. Notice that I'm adding this to object, which is the ultimate base class of everything in Ruby. So now, anywhere in my Ruby program that I have a constant name, it's just going to convert it into an ingredient for me. So if you misspell a class name somewhere, it's going to become an ingredient all of a sudden. And that's probably not what you wanted. So this is a little bit too much. You have to be careful anytime you're using open classes not to make these huge sweeping changes that are going to affect everything in the world, like object. In fact, the very early versions of Mocha and FlexMock, you couldn't use them both in the same application because they fought one another, because they both made changes to some core important objects way up the hierarchy, and they were incompatible changes. Fortunately, people have figured out a way around that now, and they don't do that much anymore, but it's definitely an issue. So you don't want to do this. This is better. I want to use the Ruby language feature of a module to create a mix-in so that I can mix in an ingredient builder into any class that I want it to automatically resolve as an ingredient when you have a constant in it that, Ruby doesn't know what it is. And this is taking advantage of this feature of Ruby called append features. This automatically gets called anytime you mix in a module to a class. And what it's going to do is put the constant missing on whatever that target class happens to be. So that means that any class that I want to automatically resolve to ingredients, I just include ingredient builder, and now that class, anytime you have a constant in it, it'll convert it to an ingredient, but then all other classes won't do that as well. So basically that limits the scope of that change to a very narrowly defined place. And that's exactly what you want to do, is try to narrow those kinds of changes as much as possible. It's not evil to create really fluent interfaces like this in Ruby, but you should do it with a light touch, not with a hammer. And since I'm doing this anyway, I can make my constant factor a lot smarter, because now what I can do is create a hash of common and not so common misspellings of ingredients and correct the spelling. So I've basically created an ingredient spell checker here as part of my mix-in. So I'll let my idiot users spell flour like that, and nutmeg with a K, which nobody would probably ever do, but you never can tell what users will do. And now what this does is in the constant missing, it goes and checks, do I have one of those keys in that hash? If it does, it creates an ingredient. Otherwise, it yells at them and says, I'm sorry, I have no such ingredient. And in fact, here's a test that shows that including my smart ingredient builder, flour and flour both get resolved correctly as constants. And this guy doesn't, because that's not one that I've put in my little dictionary of possible ingredients. This is a good example of a DSL anti-pattern, which I call the shotgun approach to open classes. Don't provide universe-wide access to wacky stuff you've implemented for your DSL. There's a temptation there to do some really crazy stuff to make your DSL really special, but it will almost always come back and bite you in the end. Another way of saying this is control your context. Control the context in which your DSL is going to execute so that you know exactly any changes that you've made to core classes or anything like that. You know that they get resolved correctly and they don't do damage outside the context of where they're meant to operate. Which brings up this context word again. And one of the ways that you can make DSLs friendlier is to use an implicit context to make them terser or tersify a DSL. And this is used a lot in the DSLs that are popular out of the Ruby community, like shoulda or RSpec or Dust or a bunch of the DSLs that are out in the world. And here's an example of that. Notice that this is my recipe adding code again. And notice that I'm having to repeat recipe over and over again there. And that kind of repetition is exactly the kind of thing you're trying to get rid of in a DSL, because you're trying to move it away from looking like a regular API and more toward looking like natural language or something along those lines. And so I can get rid of all those recipe.adds by supplying a context for it to execute within, like this. I've created a method on recipe called consists of, which takes in a block, and within that block, it's assumed that these are all going to be things that get added to recipes. So that's an example of creating a wrapper context to make it so that you don't have to have as much repetition. And in fact, the way to implement that is very trivial. My consists of method takes in a block, and it just says instance eval that block. An instance eval in Ruby is very, very handy for this, because instance eval evaluates Ruby code by switching self to the instance of the object calling instance eval. So within this, when you call instance eval, it basically says, okay, whatever object I'm within, I'm going to switch self to that just for this block. Call some code like this, recipe.consists of, what it is basically doing there with the instance eval is taking this recipe context and automatically adding it as an implicit dot, object dot in front of each one of these methods that get called. So instance eval is really good for creating these wrapper contexts like this, because it lets this object recipe become self just for the body of this block, which means that all the methods that get called on that actual class. You see this done a lot in, for example, RSpec and shoulda, where they have these containing blocks where they open curly braces, and a lot of times they're using the same technique inside there so that the methods you call in there don't have to have qualifiers. It's just whatever the wrapping object is. Okay, I've talked about 2 of the 3 different ways that you can supply context for DSLs: method chaining, nested method, and the last one of these is a variation of this called functional sequence. Using a wrapper, for example, like a closure, which is this last example was using a closure, to supply context to a linear sequence of method calls. You'll notice this is the exact same problem that we solved with method chaining. It's a way of supplying a context so that you can make a series of method calls without having to repeat a lot of stuff. In the method chaining example, every method returns self, so you could all chain them together. In the functional sequence example I just showed you, you're using a closure block to supply a context for all the things that get called within that closure block. But they're really just 2 different ways to solve the same problem, which is to supply an implicit context for the things that you're calling. This is another pattern called expression builder. And the example I'm going to use here is an addition to my because if you're going to create recipes, if all you're really trying to capture are the names and quantities of the ingredients, it's a waste of time to create an entire DSL for that, because that's really just data. And you'd be better off just storing that in some other more reasonable format. But having it in a DSL means that not only can you keep track of amount of ingredients and ingredient type, but you can execute other code inside that DSL as well to do stuff like a nutrition profile. So one of the things you might want to do is anytime somebody puts together a recipe with flour and nutmeg and all that stuff, keep track of what the nutrition profile of that recipe is going to be, how much fat and sugars, et cetera, and all that would be completely hidden to whoever's writing the recipe. They just fill out all the ingredients, and at the end, you could say, okay, what's the nutrition profile for this? And that's basically what I'm going to create here, is this nutrition profile that for each one of the ingredients, it gets the profile for that ingredient from a nutrition profile database,